So, time is coming. Thank you very much for your attendance. So, good afternoon, everybody. Today, we will have a special lecture spoken by Professor Teppei Yamamoto. I am Kazumi Shimizu, the professor of this department and the leader of top global university program and Waseda Institute of Political Economy. I am very honored to be a moderator for today's special lecture. Professor Teppei Yamamoto, he is now Associate Professor of Political Science at MIT, Massachusetts Institute of Technology, and faculty affiliate of the Statistics and Data Science Center at the Institute for Data Systems and Society. And he directs also the Political Methodology Lab at MIT's Political Science Department. He graduated from the University of Tokyo. After that, he got a master and doctor degree in politics from Princeton University. As you have already well known, he has published a number of papers in the top journals, such as American Journal of Political Science, APSR, Journal of the American Statistical Association, Political Analysis, PNAS, and so on. And also, he is well known as one of the leading scholars regarding causal inference. This is one of the reasons why today's title is Causal Explanations in the Social Sciences. Today, we also have another special guest, our president of Waseda University, President Aji Tanaka. He comes to give us an opening remark. Now, so first, please welcome President. Give him a big applause, please.
Thank you very much for your introduction, and you are welcome to be here. And it is my pleasure to give you some speeches, and then it is our pleasure to welcome the Professor Teppei Yamamoto. And let me talk about a little bit about our history of relationship with Teppei and us. Okay. Okay. When he was a graduate student at the not University of Tokyo. After he graduated from University of Tokyo, he went to the Princeton University. And then when he was a graduate student at the Princeton University, we here at the Political Science and Economics in this building, we started global COE for the political economy, positive political economy. And all of us, like Masaru Kono, Kazumi Shimizu, Ikuo Kume, us were Koichi Suga and so forth, and we are doing all the kinds of new programs, positive political economy thing, and then we started collaborating with the Professor Kosuke Imai, who is used to be professor of political science at Princeton University. Now he's at Harvard, and Kosuke Imai, I assume that all of you are interested in data science or analyzing big data and so forth. And one of the leading scholars, maybe not one of the leading scholar in Japan, also in the United States, in that area, in political science, is Kosuke Imai. And he graduated from University of Tokyo. He went to Harvard, and he got PhD in political science and MA in statistics. And he got a position at Princeton University. And he has been producing many great leading scholars in political science, particularly in the field of data science, data science. And then Teppei is one of the first product of Kosuke Imai. And he got PhD from Princeton University and got job at MIT. And after that, and many bright students gathered to Princeton under Kosuke Imai, Professor Kosuke Imai. And thanks to him, thanks to Professor Yamamoto's success. And we have been, coordinating with Professor Kosuke Imai and Professor Teppei Yamamoto. And actually, he came here to give us, lectures couple of times before, maybe twice or 3 times before, and every time, all in English, and every time he explained far higher level of statistical analysis than I could understand. But we have been enjoying. And today, this is very interesting, top-notch scholarly work in causal explanation, causal inference. And actually, when I was a graduate student at Ohio State University in 1984, 1985, I did a path analysis, causal analysis. But the level of the causal analysis we did in 1985 or something is far behind compared to what he is going to talk about. He is going to talk about the very top-notch, very advanced, leading level of the causal inference. And thank you very much. And please welcome the Professor Teppei Yamamoto. 途中で出ますけど。はい、わかりました。じゃあまた後ほど。
Okay, so thanks very much, Tanaka-sensei, for the very kind introduction. I've been very happy to be part of the Waseda Seikei community in some sense. I have been here to give a couple of talks, and today, so I'd like to give kind of an overview of my research on what I would call the causal explanations, addressing various aspects of causal explanations for the social sciences. And sorry, I'm trying to make this work. Okay, all right. Okay, so so what I'd like to do for the next, I guess, 50 or so minutes is to give basically like an overview of the various projects I have been working on, and then I want to put those in the context of what you might call the identification revolution that has been happening in the social sciences for the past 10 years. Okay, so so basically, so since the beginning of the 21st century, I would say, there have been many important developments in the applications of experimental and quasi-experimental methods in various fields of social sciences, especially in the political science, which is my own field of, which is my own discipline. It's been an explosion of these applications, appearing in top journals and also migrating into the policy world as well. So I would say that causal inference has now become part of what you might call the normal science. So it's the methods that we might call the causal inference methods are very routinely used in the standard empirical research in political science. So if you open a political science journal and look at the empirical sections of the papers, then you're very likely to see one of these causal inference methods being applied and they used as the main way of presenting the results. Okay, and in fact, so when I started grad school, causal inference was taught as a very special topic, and I was lucky to have, one of the, as Taka-sensei mentioned, one of the leading scholars in political science on causal inference. So I was fortunate to take a class on causal inference when I was a graduate student. But at that time, in most other programs, the very top programs in the United States, didn't have like a proper, causal inference class for the, graduate students in political science. Nowadays, if you look across the top programs in the US, then almost all of those have causal inference class as part of the standard method curriculum. In fact, the other big reason why I'm here is to actually teach a course on causal inference in the political science and economics department here, and I'm very glad to see some of the familiar faces from the class sitting in this room, so I'm very happy to see my students coming to this lecture too. But anyway, so this is actually become a routine part of training as well. And also in the policy world, you might have heard the term evidence-based policy making very frequently, in the past few years. So this is where, people use the causal inference type of approach to evaluate evidence in order to make sure that the policy, the government is proposing is actually, effective, right? And also, you might have heard very recently that this year's Nobel Economics Prize went to the research on experimental that employs experimental methods. So it's very indicative of this, widespread use of causal inference methods that, the economics, which I think is the, in many ways the forefront of social sciences, is basically endorsing this approach as a main approach to empirical analysis in the discipline. So nowadays, I would say it's increasingly harder to publish empirical work without a clear causal identification strategy. So you actually have to justify the assumptions that go into, show your result being a causal estimate as opposed to just a correlation. And, so when this movement started at the beginning of the 21st century, there were some people saying this must be a fad. It's going to just fade away in a few years. But, given the development in the past, 10 years, I would say 10 or 20 years actually, I would say this is clearly not a fad. It's actually part of the normal science now. Okay? So given this background, it's still not the case that everyone is kind of fully endorsing this way of doing social science, right? The causal inference, what I would say, the causal inference paradigm is not without critics. Okay, so I'm gonna look at a few main kind of points of contention that surrounds the social science, political science, the causal inference application in social science. So one is the theory versus evidence kind of debate, which is, so by kind of virtue of, basically founding everything in the formal framework for defining the causal effects and clarifying the assumptions for identification, people tend to now prioritize empirical credibility over kind of theoretical, interesting theories and theoretical insights. So it becomes, one important question, we might all ask as a social scientist is, we see like a bunch of experimental results that are individually credible and believable as an internally validated estimate of causal effect. The question is, how do those parts add up to the whole, right? And then there have been famous complainers of this tendency among the graduate students. So as graduate students, you write a dissertation. You can't do everything as a graduate student in dissertation. Students nowadays very much prioritize having a very credible identification strategy, and then sometimes they kind of leave the theoretical part, as a side, something that they don't prioritize. So Francis Fukuyama, Angus Deaton, they have, written about this tendency, and they are not very happy about that. And I have many of my colleagues who are part of this disgruntled thesis advisors. So, so this is still an important issue. Another way of slicing this kind of contention is the external validity versus internal validity debate. So, the causal inference paradigm, I would say, prioritizes internal validity over external validity. So they say that, you want to establish the causal effect is identified and well established within your sample, within your study, and then only after doing that you can talk about generalizing this to other contexts, right? But, so many people feel that's going to, make it very difficult to actually, make political science or social sciences useful, because causal effects in the social sciences deal with people and society, and they are inherently highly context dependent. It's very important to think about causal effects that are heterogeneous across different people, different units, and even perfectly designed experiments. So if you were to run a perfectly designed experiment, impeccably executed, and look at the causal effect, and then you try to replicate it in a different context, then you may just fail to replicate it, not because your experiment was bad, but because the effect was inherently heterogeneous, so that you can't actually hope to replicate that unless you are lucky to have completely comparable units in your sample, right? So the case in point is the open science collaboration's famous psychology replication paper that was published in Science. So they actually ensured, only a small number of, the well-regarded results in social psychology were replicated when they tried to replicate their studies. And, people talked about why this was the case. One of the reasons people talk about is, so these experiments were, based on a theory that's very highly context dependent, even though those are supposed to be universal because they are psychological theories. And then, the replications do not really get at the exact same population of subjects the original studies used. That was, So if that was the case, then, you know, if there is no hope to generalize your result in experiment, you know, what does it mean to actually have an internally valid study? Is this any useful, right? So that's an important point of contention. The last point, which I don't think has received as much attention as the other 2 points, is actually this long-standing dichotomy between explanation and prediction in philosophy of social science. So when I took like a research design class or a social science methodology class when I was much younger, as a first-year graduate student or even as undergraduate, you know, one thing, you know, people talk about is, should social scientists aim at prediction or just explanation, right? What's the goal of social science? Should we try to be forecasters of elections and then we try to make predictions about how society would evolve? Or we should be focusing on explaining what happened, explaining and interpreting the social events, and then develop some, you know, framework to understand, you know, the society. So that was kind of the, you know, important kind of dichotomy people talked about. And many people sided with the explanation side, saying the predictions are for the forecasters. We don't really want to do that. We want to understand what's happening in the society, right? So that's the debate. So my question, I want to ask a question, you know, how the causal inference revolution fits in this kind of dichotomy, right? So, you know, so on the one hand, you know, if you learn causal inference is often juxtaposed with the predictive inference, saying, you know, causal inference deals with causation, predictive inference deals with, you know, forecasting, regardless of causal relationships. So that's how people feel about it. But I actually feel differently, in the sense that if you situate the causal inference in the context of this long-standing, you know, dichotomy between explanation and prediction, I think causal inference is closer to prediction. So after all, the causal inference statistically is just a counterfactual prediction problem. So when you say the policy, there is a certain policy that caused, you know, decrease in the unemployment rate, for example, right? Then that is going to be used to forecast or predict the, you know, possible impact of the hypothetical policy you would implement. But that's not going to be used for explaining why this policy actually got to decrease the unemployment, right? So we don't really, the causal effect itself, you know, is not going to, experimental results themselves are not going to directly help you explain in a way that's much appreciated by social scientists. So the question is, does proving X has a causal effect on Y always help explain Y? So of course it does contribute to the explanation, but the question is, the standard causal inference methods and approaches tend to focus on proving this simple causal average relationship, you know, without regard to actually helping social scientists to use those results to explain things. Okay, so that's the kind of the context I want to situate my research, various projects in. And so what I want to basically do in my research is to push the envelope. So I found this diagram on Wikipedia. I always thought that pushing the envelope doesn't mean something like pushing the envelope function, but, you know, apparently people think of it this way. That was funny to me. But anyway, so I want to kind of push the envelope and try to kind of enrich the content of causal inference methodology in order to start answering questions about why and how. Okay? So the standard causal inference methods are targeted at, you know, often targeted at what's called the average treatment effect, ATE, often known as ATE, and its local variance. Okay? So randomized experiments matching instrumental variables, RD, diff in diff, those, you know, standard methods, you know, basically try to estimate the ATE of various kinds. Okay? Then, so these questions often, you know, usually correspond to asking, would setting X to some value X as opposed to X prime by intervention change Y on average? So that's the question they can answer by applying these methodologies. Okay? So this alone is often insufficient to satisfy the critics of causal inference paradigm, as we reviewed in the previous slide, who often have more nuanced causal questions and or more ambitious theoretical targets. So the question is, can we kind of extend the framework or enrich the framework in order to start getting at those questions? Okay, so I want to, assuming the time permits, I want to kind of review 4 areas which I have been working on that belong to this broad research agenda, which is to kind of pushing the envelope of causal inference. Okay, so the first is mediation. Why does X cause Y? So that's an important question to answer. So I have been working on the mediation methods for some time, actually since the grad school, to get at this question. The other way of thinking about why is to think about the components of a treatment. Often the treatment itself is a bundle of different components. So, by designing an experiment that kind of decomposes these components, you might be able to get at the mechanism in some way. So that's another approach I have been, looking at. And then more recently, I have been thinking of unifying the 2 approaches to get at the, single kind of the quantity of interest that captures the mechanism, what we might call the mechanism, and then use actually the, components approach or the moderation approach in order to get at the mediation question, basically. So that's something I have been working recently. And then finally, if I have time, I want to talk about the explanations more directly by kind of trying to bridge the gap between the experimental results that speaks to the average effects in the sample to explaining what happened in the real world using these causal results. So that's basically what I want to get out eventually for the rest of this talk. So before I begin, I have 2 disclaimers. First, this is not a comprehensive review. I basically talk about my own research, so don't think of this as a comprehensive review of these topics. And my focus is on the topics I worked on. The other thing is do not expect miracles. So one common theme that kind of comes out of these researches is that if you ask more from the data, then you actually have to pay more in the form of making more assumptions, right? So, or in the form of designing and implementing design that's more complicated and also more costly to implement. So, unfortunately, I can't give you a magic to do all the, solve all the mechanism questions, with some statistical magic. But but this is where we are at. Okay, so if you came here to get something that completely transforms your research practice, then you're not in the right room. Okay, all right. So let me start with the first topic, which is mediation. Okay, so this is something I have been working on, as I mentioned, for some time. So I'm going to start with the very basics. You might heard of that, when I gave a talk at Waseda 10 years ago. But I'm going to start with that, and then I'm going to talk about more recent developments. Okay, all right. So the mediation is a way to think of the causal mechanism under the potential outcomes framework of causal inference as causal pathways. So the simplest kind of mediation can be summarized by this kind of diagram. So we have the treatment. I'm going to use T in this section to denote the treatment. Okay, the outcome variable, it's Y. So I'm interested in the effect of T on Y, but not just I'm not just interested in estimating the effect of T on Y, but also I'm interested in why T affects Y, how T affects Y, what variables transmit the effect of T on Y. Okay, that kind of gets at the why question in some ways, right? It's the one way to think of the mechanism. Okay, so the quantities of interest in this context is not the average total effect, but the direct and indirect effects. So what's the indirect effect will be summarized by these 2 arrows, right? Basically meaning what the portion of the treatment effect of T on Y that's transmitted through the change in M. Okay, that's what I mean by the indirect effect or the mediation effect. Okay, the direct effect is represented by this black arrow in the bottom. That's basically the effect of T on Y that's not transmitted by the mechanism of interest in M. Okay, that goes through something other than M. Okay, and then so this kind of quantifies how treatment affected Y. So quantifying how is basically what we are doing here. Okay, and then there has been a fast-growing methodological literature on this kind of methodology. Right, so the framework. So I want to talk about some notation. It might be a little bit boring, but this is the basis of everything I'm going to talk about. So I want to fix the notation first to make sure I'm talking about something that's well defined. Okay, so I'm going to adopt the potential outcomes model of causal inference. The students in my class should be very familiar to this now. Okay, after solving all these problem sets, right? And so I'm going to use T to denote the binary treatment. It's that, so 0 means the control condition. The T means receiving some kind of the treatment of interest, the treatment condition, okay? So we're interested in the effect of T being 1 versus T being 0, okay? That's what I mean by the causal effect of T, okay? And then, so I'm going to introduce 2 other variables, the mediator and the outcome variable, as, represented in the causal diagram I presented, in the previous slide, okay? And then I also want to, I'm going to sometimes use this X denoting observed pre-treatment covariates. So these are the covariates, other variables in the data set that's not affected by the treatment. That's why I call this pre-treatment, okay? I might utilize those variables, okay? Right? And so now I'm going to use the potential outcomes framework or the notation to denote what would happen to each of these variables M1, Y under alternative state of the world. So basically we think about, when we think about causal inference, we think about comparing counterfactual states of the world, right? So what we want to think about is, let's say I'm interested in the effect of T on M, right? If that's the case, what I want to do is to compare what would happen to M if observation, if unit I, so let's say this I, little I, index, subscript I, indicates a particular person or unit in your sample, okay? So the yi of, so if I want to think about the effect of T on M, what I'm thinking about is the comparison between the value of Mi if I was under the treatment versus the value of Mi if I was under the control, right? So I'm gonna denote that using this what's called the potential outcome notation, which is this parentheses, right? So this means this is Mi of 1 or 0, so T is either 1 or 0. So Mi of 1 is the potential value of the mediator for I when observation I was in the treatment group, okay? Similarly, Mi of 0 is going to be the value of the mediator when I was in the control group, okay? So we can think of the effect of T on M by comparing Mi of 1 and Mi of 0, okay? That's the potential outcomes framework, okay? So that's for the mediator. But what I'm interested in is not the effect of the treatment on the mediator per se. I'm interested in the effect of the treatment on the outcome that's transmitted through the mediator. So I have to introduce the outcome variable too. Now, according to the diagram I showed you earlier, the outcome variable Y is affected by both M and T. So what I have to do is to think of the potential outcome in terms of these 2 things that causally precede Y and M. So Y of T and M. Okay, and then so this is the potential outcome I would get when I was in the treatment status T and I got the mediator value of M. Okay, and since M is also affected by T potentially, the observed value of Y is going to be this nested counterfactual, which is what would happen to Y if T was set to the actual value I got, and then M was the value that would realize when I got the value of the treatment that was the actual. Okay, so that's the the nested counterfactual that corresponds to represents this 2 steps of causality in this framework. Okay, the problem is just like in standard causal inference problems, we only get to observe one potential outcome because I is either in the treatment condition or the control condition. So we don't get to observe both conditions at once. Okay? All right. So with this, I can define, I can formalize the notion of causal pathway by looking at this thing called average causal mediation effect. Okay? So so the top, what's on the top is the standard 80, the total effect of the treatment on the outcome variable. Just making explicit that the effect goes through the mediator. So that's why I'm explicitly writing down this intermediate variable M as part of the notation. Okay, but what I'm interested in is this quantity. This is called average causal mediation effect. This represents the combination of those 2 red arrows on the previous slide, right? This basically says what's the effect of what's the effect of changing M from the value that would be realized under the treatment and then to the value that would be realized under control. Okay? So this is the effect of M on Y the change in the M on Y, that would be induced by the treatment. Okay, so the difference between M1 and M0 would be the effect of T that's induced by the treatment, right? And then we are interested in the effect of that change in M on Y. So that kind of captures the notion of the effect of T going through M with like two changes. Okay, so that's basically how we can formalize the indirect effect. And note that in this notation, I fix the T itself, the direct value of T, constant, so that I'm taking out the direct effect of T on Y that doesn't go through the change in M. Okay, so that's how I can formalize this, the indirect effect in the causal inference, the potential outcomes language. Okay, and then similarly, I can define the other portion of the causal effect as an average natural direct effect, and I can show that pretty easily that the total effect is the sum of these two things. Okay, mathematically that's true. So I basically formalize the decomposition of a total causal effect into two portions. Okay, all right. So now the problem is, can we identify and estimate these quantities? So these quantities seem to be interesting, right? These seem to be well defined and put on the causal inference language, so they are causal effects. So it's interesting and captures the idea of causal pathways. So I want to estimate it. The problem is, observed data is not going to be directly informative about that effect. Okay, so the problem is that this thing is observed, but this thing is not observed, because I'm talking about what happened to the outcome when the treatment was this value, but the mediator was the value that would realize under the other value of the treatment. Okay, so that's a counterfactual value. That's pure counterfactual. So it's impossible to observe that value. That's a component of this causal effect. Okay, so this is a situation where we say we have an identification problem. So in order to make progress, we actually have to think of a solution. So the one way to make progress is to think of an identification assumption that we can make to make this quantity identifiable. Okay, so one of these assumptions is called a sequential ignorability assumption. So so it's kind of hard to decipher what's going on. But basically what it says is, first, the treatment has to be randomly assigned. Okay, the first equation, the first relationship means the treatment T is randomly assigned. So it's like a randomized experiment where you randomly assign people to different treatment groups. That's one. Two is the real assumption, because the first assumption is satisfied if you can randomize, the experiment, right? Randomize experiment, right? But the second assumption is a true assumption in the sense that this is something you have to make, as opposed to control, right? So basically what happens is we have to assume that the actual value of the mediator that realizes is going to be also as if randomly assigned if you take into account the correlation of, M and Y due to the treatment and the other background covariates. Okay? So another way of saying this is if you compare two units that are identical in terms of the background covariates that are not affected by the treatment, as well as the treatment condition they were assigned to, then which actual value of the mediator they happen to get is as if random. Okay? So we have like, as if random mediator value. That's the assumption we have to make in order to identify the indirect effect. Okay? And so in that paper, we kind of show that this assumption is, sufficient to identify these these quantities. Okay, all right. So here's some examples how this might be applied to the real data. So we can actually take this identification result and then turn it into an estimation algorithm. And in a separate paper, we talk about how to estimate the quantity once make the assumption using various statistical models. Okay, and so here are some examples. I don't have time to go into the details of these examples. I'm just gonna give you a sense of how it might work. Okay, so this is an experiment where the authors, Brader et al., tried to estimate the effect of different media framing, the news stories about immigrants to the United States framed differently. So one version was portrayed as a negative experience of a Mexican immigrant. The other version was framed as a positive experience by a Russian immigrant. So they are trying to estimate, basically identify the effect of, this different way of framing same story, and then how that might affect people's opinion about immigration. Okay, so that was the question. Yes. Who? So mediator is a variable, not a person, right? So the mediator, so I was going to get to that. So the mediator in this context was their perception about the increase or decrease in the immigration. So they hypothesized, they wanted to compare whether the effect of the treatment on the outcome variable goes through the factual perception or something else. That was their original question. And then so what they did in the original paper was to apply what's called the product of coefficients approach. So this is what they show in the original paper. What I want to talk about is the mediation effect estimates. So these are the quantities I defined earlier on the slide. Okay. So on average, so basically this says that on average 10 percentage points of difference is going to happen because of the effect of the framing on the outcome that goes through this change in the perception, factual perception about immigration. Okay? And then we also developed a sensitivity analysis, what's called a sensitivity analysis, which is because we had to make this assumption about identification, we just don't want to say, I make an assumption and stop there, and then just keep believing in that assumption. Because that assumption is something you can't verify or you can't justify by design. So we need to probe into the possibility of assumption violation and then see the robustness of the estimate as a function of the degree of violation. So what you can do is to basically quantify how severely this assumption, the key identification assumption, the as-if randomness of the mediator, is violated with a parameter rho. Okay, so I can't go into the details of how this is defined, but think of this as a parameter that represents the degree of violation of that assumption. Okay, the amount of confounding that actually exists. Okay, and then so when rho is 0, then I'm assuming that assumption exactly, saying there is no confounding. So this point estimate, which is on the y-axis, is like 0.09. Okay, so that's the point estimate under the assumption. What I can do is to vary the degree of violation. Okay, so this is going to be the positive confounding in the positive direction. This is confounding in the negative direction. Okay, and then I can hypothetically calculate the value of the ACME, that's the mediation effect, as a function of this rho. Because what I can see is that as long as rho the confounding is in the negative direction, the effect is actually going to be even larger. So I'm safe to claim that the effect was positive. Okay, for that kind of violation of assumption, right? For the other side, I can say that up until like the degree of violation that corresponds to the rho of 0.3 or so, my effect is still significant. Okay, significantly different from 0, right? So that's the kind of thing you can do, sensitivity analysis, to address the weakness of a strong assumption. Okay. All right. So another way of addressing a strong assumption is not to make that assumption, and instead think of a different research design that employs a different assumption. Okay. So in a separate paper, we talked about in different alternative experimental designs for just design for identifying the mechanisms. Okay. So here, what we talked about is instead of just randomly assigning the treatment, like in a standard experiment, what if we can randomly assign the mediator? Okay. And what if the mediator, even if the mediator is something you can't directly randomize, what if we have an instrumental variable that encourages the mediator in a certain direction? Okay? And what if we can actually run a crossover experiment where we can have 2 stages of random assignment for the same people, where in the first stage I'm going to randomize those people to the treatment, and then second stage the same people to the control, right? Can we employ these designs to identify the mediation effect? So these are the variations of the designs we discussed in this paper. So that's that's what we explored in the next step. Okay. Another way we have been trying to extend this approach is obviously to allow for multiple mediators. So what we have been talking about is only about just very simple 3-variable diagram. But that doesn't seem to be, sufficient to address all the, important questions in social sciences. So, it's important to think about the framework to, incorporate multiple variables. So, in 2013 paper, we talked about incorporating just another mediator, right? And then talking about how to think of this confounding caused by this first mediator on the relationship between the second and third mediator, second and the mediator and the outcome variable. Okay, and then here's just showing what we would get out of the methods we talked about in this paper. Okay, this is the most recent work on multiple mediators, this is called the path-specific effect estimation, as opposed to the indirect effect. So this is something I'm currently working on with my collaborators. Okay, so that was a quick run through of the mediation topic. So basically, the idea was to think of the mechanism as a causal pathway, and then think of different strategies to actually estimate the effect that goes through a particular mediator. Okay, so that that's hopefully one step closer to addressing the nuanced research questions in the social sciences. Okay, so that was the mediation approach, so the components approach. So, I want to talk about another set of research project I have been working on. This is actually kind of a factorial experiments, or also known as conjoint experiments. Okay, so the typical experiments can only identify treatment effects as a whole. So think of that immigration framing experiment example I just talked about in the context of mediation. In that, experiment, the treatment was, a story about a Mexican immigrant versus a story about a Russian immigrant. That was the treatment. Imagine you're interested in, estimating the causal effect of the difference, and then try to kind of map the, resulting effect to a theory, right? So you might, first interpret that as the effect of ethnicity, right? Where the, immigrants are from. So that actually is the, thing that's affecting people's, opinion about immigration. But, if you think about it more carefully, then being from Mexico versus being from Russia is also correlated with many other things, right? So you might perceive, someone from Mexico to be more or less educated than someone from Russia, or someone from Mexico to be more or less, skilled labor than someone from Russia. So those correlates of the ostensible treatment variable might be actually the component that's causing the difference. So depending on which of these components, you can actually attribute the effect to, you might draw different conclusions about the theory. Okay? So that's not really, clearly addressed from the standard, binary treatment assignment procedure. Okay? So what I want to do is, in this project this is very simple. Basically, to try to design a factorial experiment which contains all these components, and then try to kind of formalize what we can identify out of these factorial experiments, and then map those to the causal quantities of inference. Okay, so I'm doing this in the context of a survey experiment because I'm interested in public opinion and also elections. So as a substantive researcher, I use surveys a lot. So I'm gonna focus on the survey experimental applications, which leads to a natural method called the conjoint analysis. Okay, so this is a popular experimental design, especially often used in marketing research to analyze consumer preferences about different products. Okay, I'm basically applying this framework to more broadly to the social science problems to understand the effects of components on preferences or the choice behavior. Okay, so in this paper, Mueller, Hopkins, and Yamamoto, we revisit this conjoint method. The conjoint analysis technique itself is a very old technique that's been used in marketing, but we kind of revisit this as a tool for causal inference, focusing on this ability to, decompose the treatment into multiple components, okay? Formally analyze causal properties of this type of research design. And then we basically try to decompose treatment effect of a bundle of the treatments into attribute-wise components. Okay, so here's an example of a conjoint survey experiment. So this is one application we have looked at in these papers. So please read the descriptions of the potential immigrants carefully. Then please indicate which of the two immigrants you would personally prefer to see as admitted to the United States. And so this is like, so you would be taking a survey, you will see this comparison table, and the idea is that these are attributes of the hypothetical immigrants. We can think of these as treatment components, okay? Different attributes of immigrants making more or less, making immigrant more or less acceptable to the United States, right, from the eyes of the respondent, okay? And then, so we will be basically randomly assigning these treatments or the components, okay? So what we can do is to extend the potential outcomes frameworks to address, basically incorporate this kind of research design by thinking of, we have, in the conjoint design, we have a respondent taking multiple tasks, comparison tasks. So I use I and K to denote these tasks, and then J to denote the profiles that are being compared in the given task, okay? And then we use L to denote attributes that are the components of the treatment, right? So we have, in the previous example, we had, I think, 9 attributes that we might be interested in about, in terms of the effects. And so the treatment now is basically a bundle of these attributes. So we have a treatment matrix, which is a J by L matrix of attributes, okay? So for example, let's say we have a small conjoint design where we are comparing 2 profiles that are composed of 3 attributes. Then what we might get is a treatment matrix that's composed of the 2 profiles of the candidates, in a particular task. So that's going to be, for example, a political candidate, like, a political candidate who is a female and rich and, has a college degree versus a male candidate who is poor and has a college degree, right? And then the question is, this might affect the way people choose or prefer either of these profiles. And then we can actually think of this as an experiment where we are estimating, for example, the effect of gender, candidate gender, on respondents' preference about hypothetical candidates. Okay? So that's the way you're thinking about this. Okay? All right? And so what we want to think about now is, in this context with the bundle treatment, how can we think of the, the effect to estimate? So what's the quantity of interest? Now, if you think about the ATE, we have a bundle of treatment with like a lot of components, so it doesn't really make sense to think about the ATE for a single treatment. So how can we adapt the concept to, define something that makes sense in this context? So that's what I think about, in this slide. So we want a causally interpretable summary measure of an attribute's overall effect on the, choice of hypothetical profiles, right? So the idea is to average the effects over the distribution of the other attributes. So here's an illustration. So if we want to estimate the effect, conceptualize the effect of gender on the choice probability, what I want to do is to compare 2 profiles. One is female, the other is male, but they are identical in every other way. But I don't want to estimate that thing for just a particular set of comparison. I want to take an average of all the other possible comparisons. Okay, so these are the ceteris paribus comparisons. But I also want to incorporate comparisons that compare across different candidates, and then think of the effect of the gender per se. Okay, so basically, calculate the average of all possible comparison between female and male candidates, and average them over, and then come up with a single summary effect of gender. Okay, that's what I call the AMC, the average marginal component effect. Okay, and then that's defined in this way. And so this explicitly excludes empty counterfactuals that are not plausible, or that you as a researcher want to exclude from consideration. Like a professor with no college degree, we might not want to incorporate that as part of your inference. And you can show that this is a fully randomized experiment. So as long as you design a conjoint randomization as a standard experiment, you get to identify this quantity pretty trivially. And then we can also get at the question of mechanisms by looking at the interaction of these attributes, and how does the effect of one one attribute depends on the value of the other attributes. Okay, so that's one way of thinking about mechanism in terms of component combinations. Okay, so here's one example of what you might get out of this kind of conjoint experiment, right? So this is, the study we ran right before the 2014 lower house election in Japan. We basically ran a hypothetical election between two candidates, 2 weeks running up to the election. So people are actually in the mode of evaluating the actual subjects, and we took positions of different parties that were actually running in the election from their manifestos. So and then we summarized the manifestos into major policy areas. So this is the consumption tax policy, employment policy, monetary and fiscal policy, and so forth. And then basically each of these different values of the attributes corresponded to the actual position different parties take on in this election. Okay, and then we ran this conjoint hypothetical election experiment on a sample of Japanese voters, and then we got these results. So basically, what we get is, for example, if a candidate proposed the consumption tax policy, that's the same as the Social Democratic Party or JCP or the Communist Party, then that would have made that candidate on average 4 percentage points more popular, 4 percentage points more often supported than the candidate that's supporting the LDP, the Liberal Democratic Party position on the consumption tax policy, averaging over all possible values of the other attributes. Okay, that's what we can show in this kind of experiment. Okay, so that's one way of getting at different components of the treatments. Okay, so that was conjoint in the context of looking at treatment components. Okay, so that was part B. Now, what I'm working on now is to kind of try to integrate these two different perspectives, mediation and components, because those are both about mechanisms, but they seem to be thinking of mechanisms in completely different ways. Okay, that's kind of it's okay to have different perspectives on something as general as mechanisms, I guess. But as a researcher, I wanted to think about more carefully about what's the relationship between these two things. Okay, so what I went on to do is to think of the relationship between mediation, which is the causal pathways, and the moderation, which is the interaction effect or the effect of an attribute, as a function of what the other values are conditioned on. Okay, and so many ways to define and think about causal mechanisms. A popular perspective is mediation. The other alternative perspective is the moderation. Moderation, also known under different names as effect modification, or the components, as I referred to in the previous section, and also interaction effect or synergism. Those are the terms used to describe the common, this broad concept of one, effect of the treatment, actually varies as a function of something, that varies as well. Okay, and so these are, if you look at the formal causal inference literature done by, statisticians and methodologists in other fields, these perspectives are often regarded as fundamentally different concepts. And then they employ different models of causality. So I have been using potential outcomes to analyze mediation. But when you talk about effect modification, people sometimes use a different approach. Okay? And then if you look at the practice, so when you, again, open a political science journal, right, and then look at the empirical section, they might run an experiment and show the causal effect estimate. But if you submit that kind of paper to a journal review, what you get is, what's the mechanism question, right? The reviewer will ask, I know there is I got that there is an effect, but as a social scientist, you want to reason about the mechanisms behind this effect. And do you have any evidence, as to that? And, in that kind of situation, applied researchers do, often do both of these things. People sometimes run mediation analysis, explicitly measuring the mediator, hypothesized mediator that's supposed to represent the mechanism they believe in, and then run this mediation algorithm or the, more simple, structure equations modeling in order to get at that question. Or people find a variable that precedes the treatment, and then that's supposed to represent the mechanism of interest somehow, and then show that the treatment only affects one group but not the other. And then interpret that difference as evidence of causal mechanism. Okay, that's another way, of thinking about mechanisms. So these seem to be both plausible at an intuitive level, but the question is, how do they relate, right? Are they getting at the same kind of mechanism, or they are completely different? Okay. So, to illustrate this, two approaches. So here's a hypothetical example. So I'm not a medical researcher. I know nothing about biology. So maybe this example makes no sense. But imagine there's a paint that's apparently causing diabetes. Okay? Let's say there is a paint as in, you paint the wall and paint, right? And there is apparently paint is causing diabetes. So of course, as a scientist, you wonder why in the world this can happen, right? And it might be the case that the paint has some chemical substance that affects your hormone level in your blood. Okay, if you intake some substance that's emitted from the paint, your hormone balance changes in your blood, and then that's going to cause diabetes. Okay, so that's the hypothesized mechanism, right? And then, so let's say you're a medical researcher, you're kind of you have this maybe crazy idea, and then you want to test it. Okay, so how can we make inference about this hypothesized hormone mechanism? Okay, about the effect of paint on diabetes. So there are two approaches: the mediation approach and the moderation approach. The mediation approach is to measure the mediator of interest, as I talked about earlier in this talk, right? So you just directly measure the hormone level on people, and then try to run the mediation analysis, right? So the kind of analysis I talked about at the beginning of this lecture, you can do linear structure regression modeling. That's the more traditional approach you can use, or you can use more kind of modern or the new approach, like the mediate, procedure, we worked on. Okay, so that's the mediation approach. Okay, so what I'm gonna argue is that the moderation approach, something I refer to as a completely different way of thinking about mechanisms, can actually be understood as a way of getting at this mediation mechanism by way of using a moderator. Okay, so that's going to be useful in situations like, let's say you can't measure the hormone, right? What if you can't measure the mediator and then try to understand the mechanism that's going through the mediator? You might be concerned about a very large measurement error, or the fact that you intervene on subjects to measure this might actually contaminate the causal process, and then you kind of invalidate your whole study by the act of measuring. So in those situations, you don't get to measure the mediator. Can we still make progress about the mechanism? Okay? So in that situation, moderation approach might be helpful. Okay? The moderation approach is basically what people are doing implicitly by using this moderation approach to get the mechanism is this. Okay? So find a pretreatment covariate that switches the mechanism on and off. Okay? You can think of this moderation approach as a way of implicitly finding a switch variable that precedes the treatment variable that's hypothesized to switch the mechanism on and off. Okay? And they show that, so for example, suppose that the hormone only naturally exists in biological female. Okay? That might be a plausible assumption, right? So the idea is that if I want to prove that the effect of paint on diabetes goes through hormone, and then if you happen to know that this hormone only exists, in female, right? Then what I can do is pretty simple, right? You just compare, don't try to observe the hormone. I just estimate the effect of paint on diabetes among men, estimate the effect of paint on diabetes among women, and if I only see the effect among females, then I kind of proved that the effect is going through this hormone, okay, under some assumptions, okay? So this is the way I think of this moderation approach as a way of estimating the mediation effect indirectly, okay, using a moderator, okay? But, you might be thinking that there might have to exist some assumptions in order to justify that approach, right? So that's the project, So the project first aims at kind of clarifying that assumption and then making sure, people are actually aware of those assumptions, okay? So in order to talk about this, I think I have 10 more minutes, I guess, right? So I want to think about, the concept of this moderation using the same notation. So I'm going to introduce E as the predetermined covariance. So I refer to predetermined covariance as X. So E is one of those X's that doesn't get affected by the X. Okay. Now, what I can think of in this context is what's called a conditional AT, which is the effect of the treatment among the people who have a particular value of E. Okay. So this is this is the quantity you look at when you're interested in moderation, right? So the average effect of the treatment on the outcome among units for whom E is equal to E. So for example, this could be the effect of pain on diabetes among female patients, for example, right? So in that case, E would be gender, okay? And then we will be looking at E being equal to either men or women, okay? Right? And then we can actually, so in order to relate this to mediation, okay, I can think of the conditional versions of the ACME and the natural direct effect. So this should be ACME. So this is the conditional ACME, right? This is the mediation effect I looked at earlier, right? The exact same quantity I looked at earlier in the context of mediation, but conditional on just females, right? That's the conditional mediation effect, and same for the direct effect. Okay? And then, so we can define this E to be an effect modifier or the moderator if this conditional treatment effect is different between two groups. Okay? If this effect is actually a meaning non-trivial function of E, then we can say that this variable is a moderator. Okay? And so when you compare the effects among men and women, and then by taking difference, then what you're doing is to basically investigate whether gender is a mediator or not, a moderator or not. Okay? All right? And then so we can think of the effect modifier with respect to the mediation effects. Okay? Just to extend the concept and then to connect these two paradigms, the two frameworks. Okay? Okay? And then so here are the assumptions we need to make about the moderator in order to use this switch approach to identify the mediation effect. Okay? So first, we have to assume that the moderator or the effect modifier is specific to the mechanism of interest. Okay? So basically, what it means is that you have to assume that the difference between men and women is only with respect to this hormone as far as the effect of the treatment on the outcome is concerned. Okay? So we have to make sure that pick a moderator that's specific to the mechanism of interest. Okay? And also we have to, at some value of the moderator, we have to be able to say the effect is equal to 0, for example. We have to make an assumption about a particular group for which the effect is taking on a certain value, typically 0. Okay? Under these assumptions, what I can basically show is that the mediation effect, the ACME, is actually equal to the function of the total AT and the moderation effect. Okay? The conditional effect, and so we can actually take the ATE and then also take the moderation effect, the conditional average treatment effect, and then use those to construct an expression that's equal to the mediation effect itself. Okay? And in particular, if E is binary, like in the sex case, right, the biological sex case, then what we can show is that this mediation effect itself is equal to this difference in difference. Difference in difference is the quantity you look at when you do the moderation analysis, right? The effect of the treatment, the difference in the effect of treatment between men and women. That's the difference in differences. So that's actually that with weighted by the proportion of the group, right, where the effect is actually happening, is equal to the mediation effect itself. So what I can say based on this result actually is that the moderation is the same thing as mediation. It's actually numerically equal, right, for the units for whom the switch is on. Okay? So under these conditions, so what I would say is what people are implicitly doing by calculating this difference in difference and then this shows the mechanism. What they are doing actually is to make this assumption implicitly about the moderator, and then basically presenting the moderation effect as evidence of mediation effect. Okay? So what we did is basically conceptually making clear this relationship. Okay? So this approach is very popular and attractive for a couple of reasons. One, you don't even need to observe the mediator. Right? Notice that all we have to do is to use this switch, assumed switch, to calculate the difference in differences. And then, by virtue of this assumed connection between the switch and the mediator, then I'm identifying the mediation effect without even observing the mediator variable. Okay? So that's why, people don't have to worry about the mediator in order to claim the mechanism evidence. So that's why I think this is kind of, adopted very popularly, right? And also, in the mediation analysis, a key assumption people weren't happy about was this ignorability of the mediator itself, right? In this case, we don't need that assumption. So we're replacing that strong assumption with another possibly strong assumption, which is this direct connection between the switch and the mediator. So again, as I just mentioned at the very beginning, there is no free lunch, so we have to make some assumption. This is a tough problem to identify the mediation effect, so we have to make a strong assumption. But but now we have two approaches to get the same quantity, so we can at least triangulate different ways of identifying the causal effect, and then make evidence more robust or more credible by maybe showing the same result using different approaches. So that's, I think, something what I would call a progress. Okay. All right. So I was going to talk about preference designs too, but I want to leave room for interaction with you, so I don't want to. I'm not gonna go through. So this is basically about explaining the real world change using the experimental results. So just to give you basic intuition about what I'm doing in these projects. So what I'm interested in is, so let's say you find a significant APE from an experiment, okay? And then with that experiment, you often want to use that causal relationship to explain the real world event. So case in point is, so there is a massive political polarization in the U.S. People are becoming more liberal or more conservative, and then people are not talking to each other. That's perceived as a major issue in American politics. And people have conjectured that biased media and then the ability to just consume these biased partisan media is contributing that trend, right? Maybe people just use YouTube or cable channel to only watch Fox News and they become more conservative. That's what people are suspecting, okay? And the way to look at that question is obviously to run an experiment where you randomly assign people to Fox News or the liberal news like MSNBC, and then see whether that affects the people's opinion about political issues, right? And then in this experiment, there has been, mixed, but also, some positive evidence about the media bias affecting that opinions in the direction that's in the direction of the bias, okay? The question is, can we conclude that with that result, the media bias caused the polarization in the United States, okay? So that's the gap I want to address by this method, which is what I can estimate out of this standard experiment is basically the average effect of exposing everyone to Fox News versus MSNBC on average by forcing them to consume these, okay? So that's a valid causal quantity, and that's interesting, kind of a thought experiment. As a quantity, it's an interesting scientific question, right? But in order to use that to explain what happened in the real world as polarization, we have to explain some intermediate steps. Like in the real world, what the people who actually watch Fox News are not the people who are randomly selected, right? The people watch Fox News because they want to watch Fox News, right? Many of those people are probably already conservative, right? So what we really want to know is, instead of estimating the effect of Fox News on everybody on average, but effect of Fox News on the people who would actually watch Fox News if they were given the choice, okay? And then only with that kind of estimate, or only with that kind of quantitative interest, we can actually connect the evidence to explaining the real world phenomenon, right? So that's what I'm trying to get at using an approach called patient preference trials, okay? And so it looks like this. So this is, what we call the PICA design. This is a variant of these patient preference trials that tries to incorporate people's preferences about, revealed preference about which media to choose, and they estimate the effect of Fox News versus MSNBC news on the people who would choose Fox News if they were given the choice. Okay, so that's the basic idea. So I'm unable to go to the details, but basically we did, we ran the experiment based on the design, estimated some, estimates of these effects based on the, stated preferences, and then probed into the, plausibility of, the result, by sensitivity analysis. Okay. All right. So I'm sorry to rush through the last part, but let me actually conclude the talk. Okay. So I think it's fair to say that the identification revolution in the past 10 or 20 years has irreversibly raised the evidential standard required for social science to actually pass in order to publish the paper or in order to be regarded as a legitimate scientific discipline. Okay? So I think that's pretty fair to say. Okay? But this, on the other hand, made many theoretically interesting research questions ostensibly unanswerable, right? Because this basically, for some people, this means you have to run an experiment to, be regarded as science, right? So that's, a bad news for people who don't, study subjects that require, that can, that contains randomly assignable treatments, right? So in these disciplines, this seems to be a bad news, okay? So this means that, much methodological innovation needs to address this gap between, what scientists want to, investigate and the methods that are regarded, legitimate and valid, to use in empirical research. And one thing I want to mention is big data cannot be the sole solution because this is about designing, study in order to, identify the causal effects. And, so big data is going to be helpful, but, just, collecting a bunch of data and then running some algorithm is not going to be the sole solution. Okay? So, in fact, the design-based approaches are key to the causal questions. And as I hopefully demonstrated through examples from my own research, it's important to think about these designs, and then hopefully we're making progress for the, future. Okay, thank you so much.
Thank you very much, Professor Yamamoto. We have 15 minutes or so to have a question-reply session. Do we have any questions?
Do you want to continue in English or should I?
Maybe English is better, but it's up to the person who wants to ask you.
はい。
よろしくお願いします。
はい。
Do you have? You should have.
So thank you for your speech first. I'm going to start with a very simple question.
Yes.
So from your speech, we've already known mediator plays a very important role in our estimation. So I want to ask, how would you know if there is a mediator? Does it come from some theory or, if I want to study the treatment effect of T on Y, so why would I know whether there is an estimator or something?
Mm-hmm.
Yeah. Thank you.
Good question. In general, for almost all causal effects, there is a mediator. That's because, there is something that goes between the effect of a policy, on the unemployment rate, for example. There has been some intermediate things that are changing because of the policy, right? Yes. So the question is not to see whether there is a mediator, but to think of a mediator that corresponds to an interesting theory. So when you have a theory, then, and then you try to test that theory, right? Sometimes theory can be tested by just a simple ATE, right? But sometimes that your theory is about a particular mechanism that the treatment is affecting the outcome variable. And then you want to think about the way to operationalize that theory in terms of intermediate variable. And then once you do that, then you have a mediator of interest. And then you want to conduct a mediation analysis or other ways of getting at the mediation effect in terms of that mediator.
I see. Okay, so
Yes.
I still have another question is, in most of the equations, you showed the situation where there is only one mediator. So what if we have like two or 3 or more multiple mediators.
Right, so that complicates analysis.
Yeah.
So I went very, very quickly, but there was one slide that was about addressing exactly that problem, which is, what if there are many more mediators and what can we identify? What assumptions we have to make? So I didn't get to talk about the details of those papers, but that is a important question, and and I and some other people have been working on that question.
Okay, thank you.
In the beginning, you say that the ATE or its variant is kind of outdated, and your method are kind of different from them. But it seems to me that your estimate are also kind of average treatment effect. Like in that case, typical ATE is average over the whole population, while your estimate is kind of average over certain partial group.
Right.
For instance, in your study on the switch is kind of difference between treatment effect for male group and the female group. So it seems to me that it's kind of local ATE. So could you explain in detail how different your estimate from the classical ATE?
Right. So you're totally right that I'm still looking at the average effect. So in that sense, it was a little bit of an exaggeration to say that ATEs are bad. I mean, I didn't say that, but I sounded like the ATEs are the cause of the problems, but that's not the case. So I'm just trying to think of a way to kind of formalize the question of interest in a way that's compatible with the potential outcomes framework, so that we can actually start analyzing the quantity. So in order to do that, one way is to think of a mechanism or some other quantity of interest beyond the simple treatment effect in terms of the average effect, which is known to be tractable in the potential outcome framework. So that's the way I would probably answer your question. But so you're totally right that these are variants of ATE in some sense. Yes.
Thank you very much for the interesting presentation. I'd like to ask about, let's say, another approach of, let's say, kind of causal inference. In economics, we have, let's say, a totally different approach called structural estimation.
Right.
I mean, instead of just using the statistical method, we assume kind of economic model.
Right.
And instead of just, directly estimate the causal effect, we estimate the parameter of the model instead.
Right.
And also we assume some identification assumption about the, let's say, something in shape of the, let's say, a production function. Do you have similar approach in political science field? And also, I'd like to ask about your opinion about this structural estimation approach.
So there are some people working on the structural estimation in political science in the context of, for example, explaining strategic voting or explaining candidate behavior. So I think, so in my sense, in situations where the economic models or theoretical models are plausible, I mean, you can have strong confidence in the at least some parts of the formal model, like the shape of the function. Then I think we can reliably do structural estimation. And then so once we assume a structural model, then the line between causal inference and just statistical inference is very blurry, right? Because you basically, use your data to estimate the model. So in that sense, to me, non-parametric approach is more interesting because that seems to be, assumption-free, more assumption-free than the theoretical models. And then in political science, especially the kinds of questions I'm interested in, like the political behavior, psychology, it's very hard to think of a formal model that's reliable. So that's why I don't really gravitate towards structural approaches. But I certainly understand, in some applications, that's more plausible and more fruitful, and it's more powerful, right? Once you make a model. So yeah.
Thank you very much for the wonderful talk. In psychology and to maybe a lesser extent economics, there's a bit of a replication crisis that you mentioned going on. That we have a greater awareness about how important it is to pre-commit to a design, an experimental design, and including details such as how many subjects to run, what exact outcome you're looking at. Because otherwise, with the researcher degrees of freedom, you know, it's very easy to mislead the reader with certain, And as a result of that, I was wondering, you know, average treatment effects are already now, if they're not pre-committed, hard to trust. With the mediation analysis, is there a sense that now we have even more like researcher degrees of freedom so that it might be even less able to be reproduced, right? Even less replicable? Is there any, so I don't know political science, the literature very well. Is there a growing awareness of this? Are people trying to reproduce, see if these mediation effects are able to replicate?
Right. Great question. So this replication crisis and you know, what people might call the credibility revolution is also affecting political science in a big way, actually. So there have been efforts to pre-register the, you know, both the experimental design and also the analysis plans in political science too, especially in fields where, you know, the approach is kind of crossover with like development economics or labor economics, where they use, you know, experimental designs. And so a natural, I think, you know, logical consequence of that is if we want to run the mediation analysis out of your experimental design, then you would definitely want to pre-register which mediators to look at and then how you would analyze those. And, you know, once you take these steps, I think there is no reason to expect, you know, the crisis will be even, you know, like more severe for mediation per se.
Right. Wonderful. Yeah, that's what I was curious.
Yeah. But I know if you don't take those steps, then it definitely true that, you know, if you are allowed to introduce this third variable, there is an increased degrees of freedom on the researcher side. Yes.
Perhaps that's one benefit of the moderation approach, where the number of switches that you have might be limited. For looking at past studies before the awareness, the moderation might do a little bit better because of the limitations.
Because people have been actually starting to register the moderators too.
Right. Wonderful.
Right. That's true. Yes.
Thank you for your presentation. I'm interested in the point at where you last. I'm doing my research on observation data, which may be suffer most from identification revolution. Okay. So my question is, the identification revolution would have a very much significant effect like disaster for such observation data studies, or the revolution will improve the such observation study. I'm interested in that.
Okay, so that's a difficult question to answer for me, but I think that identification revolution raised the bar, you know, for those studies too. So you, at least, you know, you have to make explicit assumptions you will be making in order to claim your regression coefficients to be causal effects. And you have to be explicit about that. And my opinion is that, you know, it's not your fault that, you know, your question you're interested in is difficult to answer. You should be proud of tackling a challenging question. So, you know, I think, you know, given that, I think, you know, as long as you're explicit about the assumptions that you're making, and then you do take steps to kind of, you know, run things like sensitivity analysis, or these, you know, ways to address these concerns, you know, I think that, you know, credibility evolution or the identification evolution basically, you know, is beneficial to make your field, you know, more legitimate scientific discipline, I think. So, you know, I think so it's difficult because the reviewers don't share that opinion. Reviewers tend to apply the same criteria regardless of what you study. But that's a practical question. But I think, you know, normatively speaking, I think, you know, difficult questions should be, you know, judged on the criteria that are designed for the difficult question. So the criteria should be a function of the difficulty of the question you're answering. Yes.
Thank you very much. There should be other questions, but unfortunately, time to close is coming. So please give once more a big round of applause to Professor Teppei Yamamoto.
Thank you very much.
Thank you very much.